Okay, number 3, I think it is. Yeah, 2014, number 3. Um, a lot of words, but pretty straightforward problem, I think. Schools in a certain state receive funding based on the number of students who attend the school. To determine the number of students who attend the school, one school day is selected at random, and the number of students in attendance that day is counted and used for funding purposes. The daily number of absences at high school A in the state is approximately normally distributed. Mean of 120, standard deviation at 10.5. If more than 120 students are absent, um, this is the number of absences. If more than 140 students are absent, the school will lose some of its state funding in the subsequent year. Approximately what's the probability that they will lose some funding? So A, they will lose funding if it's greater than 140. So what's the probability that X is greater than 140? Right? And we know so basically we're looking at this. Mu is 120, sigma is 10.5, and we've got 140, so we're looking at what's that probability, right? Well, that's the probability that Z is greater than 140 minus 120 over 10.5. And you can look that up find the Z-score, look it up on the table, or you can do normal CDF on your calculator. If you do normal CDF on the calculator, you're just going to do 140, comma, a really big number, 999, the mean, and the standard deviation. Bingo. Oops. Oh, didn't mean to do that. 2.8% chance. So there's a 2.8% chance that they will lose some funding. B. Principal Association says, hey, instead of choosing one day, let's choose 3 days at random. And they will lose some funding in a subsequent year if the mean number of students absent for the 3 days is greater than 140. So we want to know if the probability of X bar is greater than 140. So are we still looking at the same curve? No, we're looking at the X bar distribution, or the sample distribution. And for the sample distribution, we're looking at this guy. Mu sub X bar is still 120, and what's sigma sub X bar? 10.5 divided by the square root of 3. Okay, and we want to know if that's 140. Okay, does that make sense? Now, since the standard deviation is smaller, we know, and if I actually drew these on the same scale, so let me do that. Since it's a smaller standard deviation, it's going to look more like this. So this probability is going to be actually less. Okay, so there's going to be less variability. Okay, less spread, right? Okay, so this is going to be the probability that Z is greater than 140 minus 120 over 10.5 over square root of 3. Now, you don't actually have to calculate this, but if you don't, you have to explain why it's less. Okay, it's less spread because this is the sample distribution, and there's less variability because the standard deviation is divided by square root of 3. Or you actually calculate what it is, like I'm doing, and you compare. Normal CDF 120, 140. Standard deviation 10, or I'm sorry, big number, mean standard deviation 10.5 divided by square root of 3, and you get 0.123448. so it is much less likely. Um, to lose funding using this approach. Okay. All right. C. Typical school week: Monday, Tuesday, Wednesday, Thursday, Friday. Principal believes that the number of absences tend to be greater on Mondays and Fridays. True statement. There's concern that they will lose funding if the attendance count occurs on Monday or Friday. If one school day is chosen at random from each of 3 typical school weeks, what's the probability that none is a Tuesday, Wednesday, or Thursday? In other words, what's the probability that they choose Monday or Friday of 1 week, Monday or Friday, Monday or Friday? What's the probability they choose Monday or Friday? 2 out of 5, and 2 out of 5, and 2 out of 5. Well, these are independent of each other, right? This one, and this one. So I'm just going to multiply them together. So 2/5 cubed, which would be, 8 out of 125. So 8 divided by 125 is 0.064% chance of selecting Monday or Friday of all 3 weeks. Okay, there you have it, and there they are, and it's bedtime.